Now we will solve problems on coplanar non-concurrent system of forces. Okay, problems on coplanar non-concurrent system of forces. Okay, so let us see the first problem. So a rigid plate ABCD is subjected to forces as shown in figure. Compute magnitude, direction and line of action of the resultant of the system with reference to the point A. Okay, so it is a rigid plate which is subjected to a few forces. Okay, non-concurrent system of forces. For this we have to find magnitude R, direction theta and line of action of the resultant force. Okay, with reference to the point A. With reference to the point A. So with respect to point A means point A is here. Correct? So first we will find magnitude and the direction. Later on we will see how to find line of action of the resultant with reference to the point A. Okay. So the first and foremost thing is you have to write the components. Okay. For all the inclined forces, here we have 200 kilonewton force which is inclined at 45 degree. For this horizontal component is 200 cos 45, vertical component is 200 sin 45, and we have one more force here, 200 kilonewton force which is inclined at 30 degree. For this horizontal component is 200 cos 30, vertical component is 200 sin 30. Okay, so for this force also let me write the components at the point B only. Horizontal component will be 200 cos 45, vertical component will be 200 sin 45. Okay, now to find the magnitude of the resultant force we need sigma fx and sigma fy. Correct, we need sigma fx and sigma fy. So sigma fx is equal to in sum of forces in x direction, means algebraic sum of forces in x direction. So here we have 200 cos 45 acting in left direction, sign is minus 200 cos 45. We have 100 kilonewton force acting in right direction, so sign is plus 100. Then we have 200 cos 30 force acting in right direction, plus 200 cos 30. Okay, by this you will get sigma fx. Sigma fx that you get is 131.78 kilonewton. Now we will find sum of forces in y direction, sigma fy. Okay, we have to add all the forces which are acting in y direction, that is the meaning. So we have 200 sin 45 acting in downward direction, sin is minus 200 sin 45. Then we have 200 sin 30 force acting in right upward direction, sin will be plus 200 sin 30. Then we have 100 kilonewton force acting in downward direction, minus 100. Okay, for this sigma fy is equal to minus 141.42 kilonewton. Minus 141.42 kilonewton. Now you can find the magnitude of the resultant force. We know the formula, root of sigma fx square plus sigma fy square. Therefore R is equal to root of 131.78 square plus 141.42 square. 141.42 square. I am not taking the negative sign because if you take minus 141.42 whole square, minus into minus, it becomes plus. So directly I am taking the values with positive sign only. So by this you will get the resultant force as 193.3 kilonewton. 193.3 kilonewton. Coming to the direction of the resultant force. Now magnitude is over. Next is to find the direction. So to find the direction, we have the formula theta is equal to tan inverse of sigma Fy by sigma Fx. Therefore, tan inverse of sigma Fy is 141.42 divided by sigma Fx is 131.78. So we have minus sign for sigma Fy. So here also same thing. If you do not consider sign while finding the angle theta, no problem. Okay, that will be okay. Theta that you get is minus 47.02. Minus 47.02 degrees. Okay, so the direction of the resultant force is known. Now what is the third question? And line of action of the resultant of the system with reference to the point A. Okay, so we have to find position of the resultant force with respect to point A. To find the position, uh, we have the formula for x-intercept, y-intercept and d. Okay, so it is asked to find the position with respect to point A, means you have to find moment about point A, sum of moments of all the forces about point A. Okay, now you find sigma ma. Sigma ma. What is sigma ma? Sum of moments of all the forces about the point A. About the point A. Now we will consider the forces one by one. First I will take this 200 cos 45 force. 200 cos 45 force into moment of 200 cos 45 about the point A. About the point A. So moment we all know it is product of force into perpendicular distance. Force is 200 cos 45. Okay, and perpendicular distance of the point A from the line of action of 200 cos 45 force, okay, is 1 meter. Is 1 meter, right? Into 1 meter. And coming to the sign about point A, the 200 cos 45 force is tending to rotate the body in anti-clockwise direction. Sign is minus. Sign is minus, which means assume that this rigid plate is free to rotate about point A. Okay, assume that the plate is hinged at point A. It is free to rotate about point A. In that case, if you apply a leftward force at the corner B, what happens? The plate will try to rotate in anti-clockwise direction. So the sign is minus, anti-clockwise moment. Okay. Then coming to the moment of 200 sin 45 force. 200 sin 45 force. 200 sin 45 is the force into perpendicular distance. When it comes to the perpendicular distance of the point A from the line of action, there is no perpendicular distance here. Point lies in the line of action of 200 sin 45 force. See, this is the line of action of the force, correct? Line of action of the force. So point lies in the line of action of force. There is no distance of point A from the line of action. So distance is 0. Distance is 0. When the point lies in the line of action, distance becomes 0. Okay. Now we will take moment of this 100 kilonewton force. You put plus or minus, it will be 0 only. 100 into perpendicular distance from the line of action of the force. See, just see the line of action of the force, 100 kilonewton force. So this is the line of action of 100 kilonewton force, correct? It is horizontal line of action. This is the line of action. So here is the point A. Distance of this point A from line of action of 100 kilonewton force is how much? Again it is 1 meter. 1 meter into 1 meter. Okay. So remember like this, if the force is horizontal, distance will be vertical. If the force is vertical, distance will be horizontal. And if the point lies in the line of action, distance will be 0. Like this you can remember. See here 200 cos 45 is horizontal and distance will be vertical. Distance of point A from the line of action of 200 cos 45 will be vertical, that is 1 meter. And 100 kilonewton force is horizontal. Okay, 100 kilonewton force is horizontal, distance should be the vertical. Okay, distance of point A should be the vertical from the line of action of 100 kilonewton force. So this is the line of action of 100 kilonewton force. 100 kilonewton force. So vertical distance of point A from the line of action of 100 kilonewton is 1 meter. This is the second case. Third case is if the point lies in the line of action of the force, means if you for 245 force, this is the line of action. Point A comes in the line of action of force, so distance will be 0. This is how you need to remember. Okay. So still, if you have any doubts regarding finding the moment, you can uh, comment in the comment section, so I can clarify your doubts. Okay. So 100 into 1 meter, and coming to the sign, about point A, as in that the plate is free to rotate about point A. It is hinged at point A. So at corner C, if you apply a rightward force of 100 kilonewton, how the plate will rotate? It will rotate in clockwise direction. So sign will be plus. Sign will be plus. Okay. Now moment of 100 kilonewton force is over. Now we will take moment of 200 cos 30 force. 200 cos 30 force. So for 200 cos 30 force, perpendicular distance of point A from the line of action is how much? Again it is 0. See, this is the line of action of 200 cos 30 force. Point A lies in the line of action, so there is no distance of this point A from the line of action. So distance is 0 into 0 into 0. Put plus or minus, it will be 0 only. Okay. Now I will take 200 sin 30 force. 200 sin 30 force into, see, the force is vertical, distance should be horizontal. So this is the line of action of the force. So this is the line of action of 200 sin 30 force. Okay, this is the line of action. So here is the point A. Distance means perpendicular distance of point A from the line of action of 200 sin 30 force. Okay, is how much? It is 1 meter into 1 meter into 1 meter. Okay, if the force is vertical, distance of point A from the vertical force should be the horizontal. Okay, if the force is horizontal, distance will be vertical, and if the point lies in the line of action, distance will be 0. Okay, so the perpendicular distance of point A from the line of action of 200 sin 30 force is 1 meter. Okay, it is given as 1 meter. Now lastly, moment of this 100 kilonewton about point A is how much? Again it is 0, because directly the 100 kilonewton force is passing through the point A. Point A lies in the line of action. Okay, so there is no moment. 100 into 0 again, plus 100 into 0. Okay, so to this we are able to write moment calculation for all the forces. Finally, if you find the moment, the answer that you get is minus 141.42, minus 141.42. The unit will be kilonewton meter. Unit will be kilonewton meter. Force into perpendicular distance. Unit of force is given as kilonewton in this problem, and unit of distance is given in terms of meter. So unit will be kilonewton meter for the moment. Therefore, sigma MA is equal to minus 141.42 kilonewton meter. Okay. Now we have the formula to find the x-intercept and y-intercept and D. What is the x-intercept formula? Sigma m by sigma fi, mod of sigma m by sigma fi. We know that x-intercept is equal to sigma m by sigma fi. So in this case, sigma ma, we have taken moment about A, 141.42 divided by sigma fi is how much? Sigma fi is 141.42. 141.42. By this, we'll get the answer as 1 meter. Then y-intercept. What is the y-intercept formula we have? The sigma m by sigma fx. Sigma m by sigma fx. Sigma m is 141.42 divided by sigma fx we got is 131.78. 131.78. So for this answer is 1.073 meter. 1.073 meter. And D means perpendicular distance of the point A from the line of action of the resultant force. Okay, that is sigma m by r. Sigma m is 141.42 divided by magnitude of the resultant force is 193.3. 193.3. Therefore, the answer is 0.732 meter. 0.732 meter. 0.732 meter. Okay. So to this, finding the position of the resultant force is also over, and we are done with the solution of the full problem. Okay, we have completed the full solution of the problem. So magnitude of the resultant force is 193.3 kilonewton. Direction of the resultant force is at an angle of 47.02 degree, and position of the resultant force we have determined in terms of x-intercept, y-intercept, and D value with respect to the point A. Okay, which means that the resultant force, so is, so if this is the resultant force, then its x-intercept will be how much? How much we got? 1 meter. 1 meter means it will be like this only. 1 meter. And what is the y-intercept? Y-intercept is 1.073 meter. Okay, let me write the diagram as per the given thing. Okay. So here, position of the resultant force will be x-intercept is 1 meter, y-intercept is 1.073 meter. Means the resultant force is moving like this. Let me change the color. It is moving like this. Okay, from point A, x-intercept is equal to 1 meter is equal to 1 meter. Y intercept, okay, y intercept is how much? 1.073 meter. Y intercept is 1.073 meter, and D, perpendicular distance of the point A from the line of action of the resultant force. This distance is 0. How much it is? 0.732 meter. 0.732 meter. Like this, if you know the x-intercept, y-intercept and D, you can predict position of the resultant force. Okay. So no need to show the position of the resultant force diagrammatically. Okay, it is not necessary. If you just show the numbers, okay, if you just show these numbers, then it is okay. Okay, the full marks will be allotted if you just stop here. Okay, for your understanding, I have just shown the actual position of the resultant force in the problem. Okay, so to this problem number 1 on coplanar non-concurrent system of forces is completed. Thank you.